page of, I think it's called Factoring Frenzy or Factor Fest. That might be it. It says factor the greatest common, this is page 1, by the way. Factor the greatest common factor from each polynomial and simplify if possible. So we have, we're first going to look at the coefficients. We should always look and see, is there a common coefficient, which there is. And then we would look at the variables and see if there's a common, and you would also do that. Now, you don't have to put it in standard form first. You're still going to look at the same common things, but it probably helps you, and it helps you to know whether we have to factor out a negative first. So I'm going to rewrite this as 8k to the 4th m to the 3rd minus 12k squared m to the 4th plus 4k squared m to the 2nd. And this is in standard form. We go alphabetical order, k, H-I-J-K-L-M, so k is always going to come before m, and then we are evaluating each of the k's in it. So k to the 4th is going to come before k to the 2nd. So this is going to be my first term. And then we have k to the 2nd and k to the 2nd, so they're tied. So now we're going to go to the next variable, and because they tie again, because they're both m's, then we look at their exponents. M to the 4th is going to come before m to the 2nd. So all of this is in standard form now, and now we're going to look at the coefficients, and we can factor out a 4 from 8, negative 12, and 4, and we can factor out at most k squared and m to the 2nd. So that's the largest values that I can take from each of them. So if I take 4 from 8, that leaves me with 2. If I take k squared from k to the 4th, that's k to the 2nd. If I take m to the 2nd from m to the 3rd, that leaves me with m. If I divide 4 into negative 12, I get negative 3. K squared into k squared is 1. M squared into m to the 4th is m to the 2nd. Then I'm going to go 4k squared m. And so we have to do plus 1. That's the tricky part of this, because we need that placeholder. So this would be the answer, and this is completely factored. We can't factor what's inside the parentheses. And notice again, inside our parentheses is in standard form also. Number 2, we're going to look, is it x to the 4th, x to the 3rd, x to the 4th. So these are not in standard form, and y to the 3rd is going to come before that. So I'm going to rewrite this as 28 x to the 4th y squared minus 35 x to the 4th y to the 3rd plus 7x to the 3rd y. Oh, look at that. I miswrote it, because these both have x to the 4th. This is x to the 3rd. This is y, or this is y to the 3rd. This is y squared. So actually, this is not standard form. Standard form would be, this term would be first. Negative 35 x to the 4th y to the 3rd plus 28 x to the 4th y squared plus 7x to the 3rd y. Ooh, that was a little tricky. All right, now since our first term is negative, we have to factor out a negative. So we're going to factor out a negative 7 x to the 3rd y, just y. And if we factor that out, we get negative 7 goes into negative 35, positive 5, x y squared, and negative 7 divided into 28 is negative 4 x, that's the y's cancel, and negative 1 for that place value. All right, and that is in standard form, and we're good to go. We're good to go with that. Yep, that's correct. Just checking, making sure. So we see This is a fun one. This is kind of like factor by grouping. It's after that factor by grouping. So they both have this, which is being multiplied by another term. So we can factor that out. We can take an a plus b out, and if we remove it, or if we remove it, it's sort of like covering it up. So if we remove that, notice what we're left with. We're left with 2 plus 4m. 2 plus 4m, and then we would rewrite that because we would want that in standard form. It looks better as 4m plus 2, and that would be our answer. So when we factor those things out, we're going to remove it. We factor it, we pull it out, and then we would get 4m plus 2. So that's a nice little tricky one. Number 4, sorry. Number 4, we see, and this is tricky also. This is a good one, because this is kind of like y minus 2 plus 3 times y minus 2. So if we take one of these y minus 2's out of there, because they're multiplying, that's being multiplied. So if we take the y minus 2 out, we're going to factor that out. And if we cover them up, we're left with 4 times y minus 2 plus 3. And let's cover it up again. Hopefully that'll still be. Is it still? We'll see. So if we cover this, nope, it didn't work. So if we cover that up, if we pull it out, if we factor it, we factor that, what does it leave us with? It leaves us with what we had written here. 4y minus 2 plus 3. 4y minus 2 plus 3. So now we can simplify that. That's the thing that he was talking about, is you're not done here. We can distribute that 4 into it. So this is y minus 2. Let's distribute this 4 into the y minus 2, and we get 4y minus 8 plus 3. And then these are like terms. So y minus 2, 4y, it's horrible too, minus 5. So that would be my answer. Okay. Lots of little tricks and things that you need to be. So we have a common thing that is multiplying. So we will factor that out, z plus 4. And what are we left with? We're left with 3z plus 2 minus z plus 6. And that minus there is kind of important. That's the tricky part of that, because we're going to have to distribute that negative into there. So we get z plus 4. And then the 3z plus 2 is not affected. We just need to make sure we distribute that -1 to the z and the -1 to the 6, and then simplify that. So z plus 4, we have like terms in here, so that's 2z. We have like terms here, which is minus 4. And, woohoo, look at that. Don't know if you saw that. We can also factor. So I must have missed something somewhere. So we can take that 2 out of there, and that leaves us with z minus 2. So I don't know where I missed. No, that's just through simplification. I didn't miss anything. So we just always have to make sure that we're done factoring. So that would be the correct answer for number 5. So most of you are going to forget to do that factoring. All right, this time we have 3 terms that we have to factor. I again am going to write this in standard form because that's going to come before this one. So if we can take an a plus 3 out of each of these, and that leaves us with 5a plus 3 squared. plus a plus 3, because there was an extra 1, and then minus 2, because we took it out. So we're taking, well, let's do this. Let's show this again, and we can show it in a little bit more comprehensive way. So I'll show you how I saw that. So technically we have a plus 3, a plus 3, and a plus 3 plus a plus 3 times a plus 3 minus 2 times a plus 3. So if we take 1 from each, we take that one, we take that one away, we take that one away, and that provides me this term right here. And then what are we left with? If we cover it up, oh, here we go, let's go back here. If we cover it up, we cover each of those, we cover each of those up, come on. That's not going to be very, oh my goodness, that was really bad. Why? Well, it's because my pen, it's because it's a smartboard. Smartboard is being very dumb board right at the moment. So, oh, nice, of course. Well, I'm going to be, oh. Delete. So the board is acting up quite a bit. Watch me. Watch me fool you, and I can work better than you. So let's delete that. That's a, and let's copy and paste. So if we cover those things up, what are we left with? Sorry, all that work for this. So what are we left with? We're left with 5 and a plus 3 squared. That's this. And then we're left with a plus 3, that's this, and the negative 2, and that's that. So now we have to simplify all this stuff. So we have a plus 3, and I can't do this. I can't distribute the 5 into this because I have to do the squaring. So quantity a plus 3 squared is a squared plus 6a plus 9. You should be able to do that. Plus a, and we can simplify that. That's going to be plus 1. And now we have to distribute that 5 in there. So we're going to get a plus 3, 5a squared plus 30a plus 45 plus a plus 1. And we can simplify that. A plus 3, 5a squared. Let's combine these, which gives me 31a plus 46. And that should be my answer. And we will be lucky if this smartboard stays. I'm going to save it real quick because I guess we're just putting so much stuff on this. I don't know. All right, that was number 6. So number 7, we're going to factor each trinomial. Remember, 3 terms. So 3 terms. We're going to 1, is it in standard form? 2, is there a common factor? 3, is it a special case? Is it a binomial square? And in this case it is, because the binomial square has 3 terms, which this has. Second sign is positive. The first and third terms are perfect squares. And here's the tricky thing. Is my middle equal to 2 times the square root of the first times the square root of the last? So is my middle 2x equal to, this is my middle term, is it equal to 2 times the square root of the first, square root of x squared, times the square root of the last, which is 1. So if I simplify that, 2x, 2 square root of x squared is x, square root of 1 is 1, and I get 2x equals 2x. So yes, it is a binomial square. So since it's a binomial square, I know that I'm going to take the square root of the first, square root of the last, and I'm going to pull this sign in there, and it's quantity squared. It's as easy as that. Recognizing it is going to be really important. So you could do A times C, but these are going to get super complex. So it's better to recognize binomial squares. We again have three terms. So we're going to look, is it in standard form? Yes. Is there a common factor? No. Is it a special case, meaning is it a binomial square? No. It does have three terms. Three terms is check. Second sign, positive. Second sign is positive. Yes, check. However, first and third are not perfect squares. 7 is not a perfect square, so that is not. So we move down to our next thing, which is A times C. A is 7, C is 6. That gives me 42. I'm going to find factors of 42, which are 1 and 42, 2 and 21, 3 and 14, 6 and 7. My signs are the same. That's the only way I get a positive, because this is a product. This is a product. This is created by a product. So the only way we can get a positive by a product is either positive times a positive or negative times a negative. So that's why I know my signs are the same. And since they're the same, this is the summation. This is outside plus inside produces that. That's a sum of two things. And if we're adding two things, and I already know my signs are the same, well, we're either going to get a bigger positive or bigger negative. So this tells me that my signs are positives. So I'm going to go down here, and that's going to be positive, 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 positive. The signs are the same, and they're both positive. 43, 23, 17, 13. Which one of those is equal to my middle, which is 23? So I know that I'm going to use 2 and 21 as my middle terms. I'm going to split this trinomial, and I'm going to turn it into 4 terms. So I think we said, what did we say, 2? So 2y and 21y plus 6. So that goes there. This goes here. And notice 2y plus 21y equals 23y. So it's not like I changed it. I just broke that middle term into its outside and insides. That's all I did, was I created those. Now we're going to factor by grouping. We're going to group the first two and the last two, and we're going to look for a common factor. The only common factor in the first two is y, so we get 7y plus 2. In the second two, I can factor out a 3, and that gives me 7y plus 2y. Now, I know I did it correctly because these are the same. They must be the same in the A times C technique. So, much like what we were working on just before in the problems before, we see that we have a 7y plus 2 that is multiplying both things. So we can factor that out. When we factor it out, what does it leave us with? It leaves us with y plus 3. And that is the answer factored. The next one, so we see it's 3 terms. It is not a binomial square because that's not a perfect square. So we're going to do A times C. A is 1, C is negative 45. And the way I'm getting that is because our quadratic equation or expression is written ax squared plus bx plus c. So the coefficient of x squared is 1. B is negative 4, C is negative 45. So when I say A times C, I'm talking about the A value and the C value. So that gives me negative 45. I'm going to find factors of 45, which are 1 and 45, 3 and 15, 5 and 9. Now, the only way I can get a negative through a product is if the signs are different, either a positive times a negative or a negative times a positive. So I know my signs this time are different. And if they're different, we're going to combine them because this is still outside plus inside. So if the signs are different, this will tell us that we have more negatives than positives. So I'm going to give the negative to the bigger of the two factor pairs, and the signs have to be different. So we get negative 44, negative 12, and negative 4. Which one is equal to my middle term? That is negative 4. So I'm going to take these two values and I'm going to rewrite x squared plus 5x minus 9x minus 45. Now the variable for this is always going to be this variable. And that'll be important as these problems become more complex. So now we're going to factor by grouping. We are going to factor out an x, and that leaves me with x plus 5. My first term is negative in this second grouping, so I have to factor out a negative. I'm going to factor out a negative 9, and we get x plus 5. If you want to check that, negative 9 times x is negative 9x. Negative 9 times positive 5 is negative 45. So students tend to forget, and then they make the mistake there. So be careful of that. These are the same. Remember, these have to be the same. That's your visual identifier on that you did it correctly. They must be the same. And since they are the same, I'm going to pull them out. And that leaves me with x minus 9. So that's how we factor that polynomial. Let's check the old phone. Nope, everything's good. Number 10. So 3 terms, not a perfect square. So I again am going to use a times c. A is 1, c is negative 22. So I get negative 22. Factors of 22 are 1 and 22, 2 and 11. The signs are different. And the bigger is positive. So the bigger of the two factor pairs are going to be positive, and the signs are going to be different. So that's 21, that's 9. These two equal my middle. So p squared minus 2p plus 11p minus 22. Factor by grouping. We're going to factor out the p minus 2. We're going to factor out the 11, p minus 2. I know I did it correctly, and we can do it that fast. Hopefully you get so good that you can do it at that speed. All right. Well, our first term, it is in standard form, which is important. But when we say common factor, we can't. First term must be positive. First term must be positive, so we have to factor out a negative. And that's going to be 27x squared minus 24x minus 91. And this is just a mean problem, because look what our a and c are. A is 27, c is negative 91. Multiply those two together, you get negative 2,457. Finding factors of that. Have fun. There's a number of ways you can do this. We're not going to get into it, but the prime factorization is a good way of finding factor pairs. So you have 1 and 2, 4, 5, 7. You have 3 and 8, 19. You have 9 and 2, 73. You have 13 and 189. You have 21 and 117. And you have 39 and 63. Now the signs are going to be different, and the bigger is negative. So bigger is negative, and the signs are different. This gives us negative 2, 4, 5, 6. This gives us negative 8, 16. This gives us negative 264. This gives us negative 1, 76. This gives us negative, what's that, 96. And this gives us negative, that gives us negative, that doesn't give us negative 39. That gives us negative 24. Hello, 24. And guess what? That's my middle. So we're going to take those two values. So that becomes 27x squared. Instead of negative 24, we're going to write positive 39x minus 63x minus 91. Good. We are going to now factor by grouping. Factor the first two, factor the second two. So we've got that negative outside there. Let's pull out a 3x, and that will give us 9x plus 13. First term is negative. They're going to throw all the wrenches at you. Negative, what goes into 63 and 91? 7. If we factor a 7, we get 9x. And that's got to be, oh, that's minus, sorry. Minus, so that's going to be plus 13. Okay. Did I do it right? Yes, because these are the same. 9x plus 13, 9x plus 13, so you have a negative. Let's pull out the 9x plus 13, and that leaves you with 3x minus 7. Wowzers. That's a big one. That's a big one. All right. The only thing we have to be aware of is our exponents to the fourth. It's okay. We still are going to do a times c. A is 1, c is negative 3. Factors of 3 are 1 and 3. Signs are different. Bigger is negative, and we get negative 2. Is that my middle? Yes. So we are going to write, here's the tricky part, x to the fourth plus x squared minus 3x squared minus 3. Remember, this combined needs to add back up to that middle. We're not changing this expression. This expression is still equivalent. These are equivalent expressions. One's simplified. This is a simplified one. And we just rewrote this to help us with the factoring part. And notice this was x to the square, so I had to make those variables x to the square. Now we are going to factor by grouping still. Nothing changes. We're still doing the same exact thing. So we're going to factor out an x squared though. You get x squared plus 1. And we're going to factor out a negative 3. And we get x squared plus 1. We did it correctly because we have x squared plus 1 in both of the parentheses. If we take that away, you get x squared minus 3. Not too hard. Not too hard. They got some little tricks there. And we're going to continue to see tricky things. So first term is negative, so I must factor out a negative. We get k to the fourth minus 4k squared minus 21. We have a times c, 1, negative 21. 1 and 21, 3 and 7, signs are different. Bigger is negative. We get negative 20 and negative 4. So it is going to be k to the fourth plus 3k minus 7k minus 21. We're going to group. I have negative. I'm going to factor out a, hold on, k squared. K squared, made a mistake there. Thank you for catching that. We're going to factor out a k squared. We get k squared plus 3. We're going to factor out a negative 7. Negative 7, and we get k squared plus 3. These are the same. So we have that negative. Then we have our k squared plus 3. And then we have k squared minus 7. Oh, that's a good one. All right. Rolling along. Rolling along. All right. 14. So this is a binomial square. How did I know that? 3 terms. Second sign, positive. This is the first sign, this is the second sign. That's what I mean, second sign. Second visible sign. Yes, I know, it's a little contradictory. First and third are perfect squares, yes. And does my middle equal 2 times the square root of the first times the square root of the last? Yes. Since it does, since 2 equals 2 times the square root of q squared times the square root of 1, 2q, sorry, 2q, 2 times q times 1. So I'm going to take the square root of the first. I'm going to take the square root of the second, and then I'm going to pull down that sign, and then it's going to be a binomial square. So that one you really need to get good at visualizing. Is this a binomial square? Let's see, right? 3 terms, yes. First and third perfect square, yes. Second sign positive, yes. Let's look at that. Middle equals 2 times the square root of the first times the square root of the last. So 2xy equal 2 times the square root of x squared times the square root of y squared. 2 times x times y equals 2xy. Yes, that equals my middle. So I'm going to take the square root of the first and the square root of the second, and I'm going to pull down that sign, and I get it. Yep. And you get good at that when you are asked to go in this direction, when they give you the binomial square and you produce the expression. That's really good practice for students to see those patterns and what's happening. So this is not a binomial square because that's not a perfect square. So we're going to have to do a times c. And a is 6, c is 6. So we get 36. Factors of 36 are 1 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Signs are the same. Both are negative. So that's negative 37, negative 20, negative 15, negative 13, and negative 12. This is my middle. That's equal to my middle term. So this becomes 6m squared. Now watch this. Minus 4mn. It's always going to be that variable. Minus 9mn plus 6n squared. Now this is the first time it's going to get really interesting when you factor by grouping. So if we factor, we look at the coefficients 6 and negative 4, we can factor out a 2. And then we also have to look at the variables. This is m squared and this is mn. So they have a common m. So if we take 2m, we get 3m minus 2n. Oh yeah, look at that. And then first term is negative. So we're going to factor out a negative, we're going to factor out a negative 3. And then they also have an n in common. So we look at the coefficients, but we also see that they have an n in common. So when we take that out, we get 3m minus 2n. Did I do it correctly? Yep. 3m minus 2n. Take that away, you get 2m minus, that's a horrible 3n. That looks funky. That's a good one though. Two more problems. Oh yeah. So we again, it's not a perfect square. Or it's not a binomial square, so we're still going to use a times c. A is 1, c is negative 2. Factors of 2 are 1 and 2. Signs are different. Bigger is negative. And I get my middle number. So we're going to use these two numbers as my coefficients of my middle term. So x to the 4th plus x squared y squared minus 2x squared y squared. The 1 and the negative 2 came from these two numbers. Guess I should have told you that a little bit earlier. That's plus x squared. Good. Now we're going to factor by grouping. Let's group these. Sorry. Minus 2y to the fourth. And let's group these two. No coefficient, but they both have at least an x squared. So if I take x squared from x to the fourth, that leaves me with x squared. If I take x squared from x squared y squared, that leaves me with y squared. I have a negative. Let's take out a negative 2, and then they also have y squared. So if I take out a negative 2y squared from negative 2x squared y squared, we get x squared, and then we get plus y squared. X squared plus y squared, and then you get x squared minus 2y squared. That is my factored answer. Such a beautiful, these are good problems. I know they're hard, but they're good. So we have a times c, again, 8 times 3 is 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. Signs are the same, both are negative. Negative 25, negative 14, negative 11, negative 10. These are my two middles. So 8k to the fourth minus 4k squared minus 6k squared plus 3. Factor by grouping. We're going to take out a 4k squared. That leaves us with 2k squared minus 1. That's a little tricky. Factor out a negative 3, and we get 2k squared minus 1. 2k squared minus 1 times the quantity 4k squared minus 3. All right, those are the first 18. That's just the first page. Holy moly. All right, that's right. Page 2 coming up.